Okay, so we're using our properties. We know that one property of a rectangle is that when it goes from a parallelogram to a rectangle, the diagonals go from not being congruent to being congruent because it's standing up straight. So in a rectangle, the diagonals are congruent. You do need to memorize that. So if best is a rectangle, we've got BA, 2x minus 3, and we've got ET, x squared minus 6. So one of those represents half of a diagonal, and the other one represents the whole diagonal. Are you already done, Quan? Okay. So when you've got a half and a whole, you can either double the half or half the whole. I don't recommend halving the whole because you don't want to half x squared. That doesn't look pretty. So let's double the half. So x squared minus 6 does not equal 2x plus 3. It equals 4x plus 6. And then we bring everything to one side of the equation. X squared minus 4x minus 12. Is that okay? We're all getting 15? Things that multiply to get 12 that combine to get 4. 1q5? Oh, okay. Multiples of 12. Let's see, 6 and 2? Yep. 6 and 2. X minus 6x plus 2. So x equals negative 2 and 6. And then we plug it in, plug it in. What happens when we plug negative 2 in? We square it and we get a positive number. That's cool. But 4 minus 6, that's no good. That's a negative side. So we would want to throw that answer out. So then we would do, find AT. Oh, so we would plug 6 in. 2 times 6 plus 3. And all of you were already done. You were saying 15 and you were correct. I thought you could turn x squared into 2x. Tawny, if you're taking a derivative of x squared, you can, but we haven't learned derivatives in this class. I'm going to save that for your calculus class. If you were wondering, the derivative of x squared minus 6 is 2x, but that's the derivative, so that is calculus, yep. You can't turn x squared into 2x unless you are taking the derivative. Okay, moving on. Here's your homework answers. Oops. Rectangle, rhombus, square was the title of your homework. It should have been a quick one, right? Very quick homework. Check your answers. Okay, last chance. I'm going over number 7. Anything else? Last chance, last chance. Okay. Number 7, what is it asking? So every time, the first thing I want you to do is figure out, hey, what quadrilateral am I working with? And then you can start to mark your picture if you want, or you can just see what they're asking. And number 7, QSD is 40. And we want to find angle QDS. So we want to find that angle right there. So, in a rectangle, I've talked about this a lot by now, in a rectangle, when you draw the diagonals of a rectangle, you get 4 isosceles triangles. This green isosceles triangle is congruent to the green isosceles triangle, and the red isosceles triangle is congruent to the red isosceles triangle. So if that is an isosceles triangle, then I know my base angles are congruent. My base angles are congruent. So 180 minus 40 divided by 2 is 70. Was that the answer we had? I hope it was. Number 7 is 70. Yes, we had the right answer. Okay, good. Does that clear it up? It's an isosceles triangle. We gave you the vertex angle. You're trying to find the base angle. Can I solve anything else from this homework? Oh. So today we're going to squeeze in trapezoids and kites, actually. So get ready, buckle your seatbelt, because we have a lot to talk about. but then we won't have as much to talk about tomorrow. You'll just get to practice it all tomorrow. Here's some pictures of trapezoids. We've got a trapezoidal table. We've got a skylight, that's a trapezoid. We've got an opening in some like ancient ruins or something, that's a trapezoid. And we have a really pretty tower in Houston. That's a trapezoid. That's in Houston. We printed. Okay, so you need to have your family tree out. You need to have this out somewhere because we're going to be adding to it. We're going to do this side of the family tree, these branches of the family tree. By definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So not at least one, not two, but exactly one pair of parallel sides. So far, that is different from a parallelogram because a parallelogram has two pairs of parallel sides, opposite parallel sides. So that's the definition of a trapezoid. The definition is also property number 1. Oops. Let's talk about this real quick, sorry. I would label these on your family tree. I would get your family tree and I would label that trapezoid right there. So in a trapezoid, we've got some vocab that we need to go over because I'm going to refer to these as bases and legs and base angles. So your sides that are parallel, are called the bases. Base 1 and base 2. Even if I turn my trapezoid sideways, I don't want you to get confused. If I turn my trapezoid sideways like that, the parallel sides, that is still the bases. The bases don't have to be the top and the bottom. They can be the left and the right. So just be aware of that. The bases are the sides that are parallel. And then the two leftover sides, the sides that are not parallel, they're called the legs. So a trapezoid has two bases and two legs. The angles surrounding the base are called the base angles. So angle 1 and angle 2, that's a pair of base angles. 1 and 2 together are base angles. And then 3 and 4, that's a pair of base angles. You might just be like, well, then they're all base angles. But they can't be a base angle by themselves. They're like pairs of base angles. So 1 and 2 is a pair of base angles. 3 and 4 is a pair of base angles. Okay. I'm going to move on from that. So property number 1 of a trapezoid comes from the definition. Property number 1, it's got one pair of parallel sides, and they happen to be called the bases. So the bases are parallel in a trapezoid. What do you think I'm trying to tell you for property number 2? What do you think is hidden behind my invisible white rectangle that when I click it, it disappears? Yes, Tahani, I can. I can go back real quick. Base, base, leg, leg. Consecutive sides are supplementary. You didn't mean to write sides. Okay. Consecutive angles are supplementary. George, 150 plus 100 is not 180. But you're very close. You're very close. I'm giving you a hard time. So this property is a mouthful. This property is a mouthful. George is on to the right thing. This plus this, those are supplementary. And this one are supplementary. But the other two pairs aren't. So here's my property. Get ready. It's a mouthful, but we can talk about it. Two pairs of consecutive angles are supplementary. So not all of the consecutive angles are supplementary, but two pairs of angles are supplementary, consecutive. Nothing is true about opposite angles in a trapezoid. There's nothing true about the opposite angles. Let me give you another way to write this if you want. If I call the angles that surround the base angles, what would I call the angles that surround the legs? Maybe the leg angles. Now, that is not a technical term. Ms. Stanton just made that up. You're not going to find that in a textbook. If you tell that to someone else, they won't know what you're talking about. But to me, if I say property number 2, the leg angles are supplementary, That, to me, makes a lot more sense than 2 pairs of consecutive angles are supplementary. To me, it makes sense to say, hey, the leg angles are supplementary. The angles surrounding the legs are supplementary. So if you want to write that instead, or if you want to write that underneath as like another option, if that makes sense to you, you can write that. But I just made up the word leg angles. It's not a technical term. Okay. This is not a property. Don't write this down. This is just a reminder. If you take the midpoint, if you take the midpoint of a side, that's a midpoint because congruent, congruent. And you take the midpoint of a side, that's a midpoint because congruent, congruent. And you connect the dots. If you connect a midpoint to a midpoint, you get a mid-segment. So a mid-segment connects a midpoint to a midpoint. Midpoint to midpoint, mid-segment. It's not a property, I'm just reminding you what a mid-segment is. In a trapezoid, if we choose to draw a mid-segment, it is definitely going to be parallel to the bases. But here's the actual property that I'm coming to. The property number 3 on your family tree, is that the length of the mid-segment is the average of the bases. So if you draw a mid-segment in a trapezoid, its length is right smack in the middle of the 2 bases. So you add them up and divide by 2. So for number 3, you can write these words or you can write the equation. Those are the same thing. You don't need to write both. You can either write the equation or the words. So the mid-segment is parallel to the bases. It is parallel, 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 parallel. And its length is the average of the bases. Add them up, divide by 2. So what's that saying is if this is 10 and this is 20, then that mid-segment is, da, 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 right smack in the middle, 15. 15 is the number right in the middle of 10 and 20. Okay. Now we're going to move on, and our trapezoid is going to get promoted to an isosceles trapezoid. So we're going to be right here. Isosceles trapezoid. A trapezoid with congruent legs. I want you to think of an isosceles trapezoid as an isosceles triangle who kind of got the top chopped off. So if you take an isosceles triangle and you chop off the top, you have an isosceles trapezoid. So that can kind of help you picture what's going on. So just before I show you, what do you think is true about those 2 angles? If the base angles are congruent in a triangle, an isosceles triangle, they're probably congruent in an isosceles trapezoid. So here we go. We got to move fast because I still got to teach you kites too. Okay, boom. Legs are congruent. Boom. Base angles are congruent. So write those down. Lots of things are congruent in isosceles trapezoid, if you were wondering. The legs are the same length and the base angles are the same measure. So, let's say this angle is 20. Then we would have 20, 20. And then, oh, these are the leg angles, so they're supplementary. So then we'd have 160, 160. So that's different from a parallelogram where the opposite angles were congruent. Those aren't opposite. Those are the base angles. So it's working different than a parallelogram for sure. My last property, one more thing is congruent. So the legs are congruent, the base angle is congruent, and the diagonals are congruent. 3 congruent things. Oh, 3 congruent things in a trapezoid. We know what you meant, Arsham. We'll do circles later, don't worry. Quan's trying to make you feel better by putting circumference. All right, diagonals are congruent. Ready to try some? We're going to go pretty quickly, but I know y'all can handle quick. You ready? Diagonals are congruent. Okay, let's try some examples. Ooh, let's start off so easy. I'm trying to figure out who's here and who's not here. Adriana, answer X. Arsham, answer Y. Type it in the chat. All should be done by now. Adriana and Arsham. Yes, very good. So Adriana got 9, and there's 2 ways to get that. Here's way number 1. X plus 17 divided by 2 equals 13. Add your bases and divide by 2 and you get your midsegment. That's the long way. You can totally do it that way. Another way you could do it, we did this a long time ago in semester 1, is you could play leapfrog. Leapfrog! How much do you leap from 17 to 13? You leap minus 4. So you would leap minus 4 again. 13 minus 4 is 9. So that's another way to do it if you're looking for a base and you're not looking for the midsegment. And Arsham, very good. Answer is 5.5. His was a little bit easier. Well, maybe not easier. You just add them up and divide by 2. So 2.5 plus 8.5 is 11. Divided by 2 is 5.5. You knew I was going to throw some algebra at you, so go ahead and do this one. Just going in alphabetical order. Next person is Brandon. You give me X. Quan, you give me AB. And George, you give me EF. I multiplied both sides by 2 to get rid of that 2 in the denominator. So X is 28 minus 25. Yay! It's 3. And then we plug it in, plug it in. Oh, why did I ask for AB? Sorry about that. I'll give you another, I'll call on you again, Quan, because that's silly. I already gave you AB. And EF. Yes, George, thank you. 17. Let's move on. If the height of the trapezoid is 4, find the length of the legs. So how do you draw in the height of a trapezoid? It's like drawing in an altitude, okay? So the height of the trapezoid looks something like this, and it makes a right angle. It's like drawing an altitude. The height is 4. We want to find the length of the legs. Two root 5. Whoa, that was quick. Okay, let's do it to make sure. So if we've got a height there, we also have the same height here. So 10 minus 6, because this is 6, 10 minus 6 is 4, and then you have to cut it in half. So you've got 2 and 2. And then you do Pythagorean theorem. 2 squared plus 4 squared. 4 plus 16. Am I doing everything right? Square root of 20. So that's 20. We need to square root 20. 20 is 4 times 5. 2 root 5 was the perfect answer. Good job, Quan. Okay, I'm going to move on. 2 root 5 was the answer, Pythagorean theorem, and simplifying radical. Okay, here's our last trapezoid example, and then we're going to move on to kites. I think it's a compliment, George. An isosceles trapezoid has legs of length 5 root 2 centimeters and base angles that measure 45. If the shorter base of the trapezoid measures 15, find the length of the longer base. I want you to draw this before I draw it. Okay, that was a lot. Is that okay? So the nice thing was that I gave you a hypotenuse that was already 5 root 2. So that was really easy. 45, 45, 90. 5, 5, 5 root 2. And then we bring the 15 straight down. So we've got 5 here, and 15 here for a total of 25. I was nice when I gave you a hypotenuse of 5 root 2. How'd you know to put the base angles at the bottom? So, Hussein, if we've got a trapezoid, good question. If we've got a trapezoid, and this one is shorter than this one, that's the short and that's the long, this angle has no choice but to be obtuse, and this angle has no choice but to be acute, because I have my shorter and my longer. So I had to put the 45 in the angle I knew was going to be acute, because those two angles are supplementary. So the supplement of 45 is 135. 135 is obtuse. Very good question. All right, we're going to move on to kites. This is a picture of a kite festival. What city is it in? What city is that? Anyone know? Not New York. I'll give you a hint. It's in Texas. It is. It's Austin. There you go, Arsham. It's Austin. It's the kite festival that they have every year in Austin. Okay. I was gonna play a clip of Let's Go Fly a Kite, but I need to play that at the end because I'm afraid that we're going to run out of time. So remind me at the end and I'll play Let's Go Fly a Kite. Okay, how many properties does a kite have? How many? 4 properties. So we need to come up with those 4 properties. I labeled this picture with some side links. I want you to come up with a conclusion. Come up with something. What do you think? Huh. Sides that share an angle are congruent. Well, 13 and 37 share an angle right here, but those are not congruent. But you're on the right track. Take a look at that green triangle. If I take that green triangle and I fold it over, are those 2 triangles congruent in every way? 13, 13, 12, 12, 37, 37. So if I fold my kite on that dotted line, what's that called? It's a line of, we don't know if they're right triangles yet, Carson. What's that line? What's it called? If something, yes. Symmetry. Kites have symmetry. So if I draw that dotted line, everything on the top is a mirror image of what's on the bottom. Let's go over the angles. Oh, what do you notice? What do you notice about the diagonals? There's where the right angle is, Carson, that you were talking about. 4 right triangles, yep. The diagonals are perpendicular. And once again, we've got some symmetry. Look, mirror image, mirror image, mirror image. What have I not done? Mirror image. So that's how a kite works. Everything from here gets flipped here because that's a line of symmetry. Let's go over what the specific properties are. So by definition, a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Consecutive congruent sides. So that's property number 1. 2 pairs of consecutive congruent sides. And the kite stole a property from rhombus. He stole that property. Diagonals are perpendicular. They must be cousins or something. They share a trait. So a rhombus and a kite have that in common. Their diagonals are perpendicular. So every time you're given a rhombus and every time you're given a kite, I would put a box right in the middle every time so I know I've got right triangles. Moving on. This is not a property, this is just a disclaimer. One of the diagonals is going to be a line of symmetry. Now, 98% of the time, I just made that up, that number, that's arbitrary. 98% of the time, the line of symmetry is going to be the longer diagonal. Most every single time. The longer one is going to be the diagonal of symmetry. But I wanted to show you that it could be the shorter diagonal. And that's a really weird looking kite. I've never even seen a kite looking like that before. It's kind of weird looking. Sometimes, 2% of the time, the short diagonal might be the diagonal of symmetry. And you're going to be able to tell based on what the shape looks like. If it's a really weird looking kite, the short diagonal will be the diagonal of symmetry. Here's your last two properties. Whichever diagonal, most of the time the long one, whichever one's the diagonal of symmetry, it bisects the other diagonal and it bisects the angles. So it bisects the other diagonal and it bisects the angles. Okay? Let's see if we can squeeze in some examples before y'all have to go. So like I said, I recommend that in a kite and a rhombus, the first thing you do every single time is put a box where those diagonals are intersecting. Boom. 90, 90, 90, 90. Every time. Quan, rule number 1 was 2 pairs of consecutive congruent sides. And rule number 2 was diagonals perpendicular. Okay, so let's see what we can do. Here is your diagonal of symmetry. I would bold it every time. Everything on the left is going to mirror the things on the right. So, 27, 27. 14, 14. Now we can find our missing angle because we've got a right triangle here. We've got 90, we've got 14. So you're just finding the complement of 14. 86. No, sorry, 76. Whatever happens here happens here. It's a mirror. 76, 76. And then the complement of 27. 63, and whatever happens there happens there. So I found more than we needed, but that's better than finding less than what we needed. Were you okay with this? It's pretty easy. Kites are pretty easy. Once you memorize the properties. Memorizing the properties is the hard part because you've got a lot to memorize by now. Quadrilateral kite is a kite. IE is 30. KI is 25. And KT, woo, is 56. Now be careful. In a kite, one of the diagonals gets cut in half. Not both of them, one of them. So be careful about which one of those you cut in half. Find your diagonal of symmetry. Here it is. Find your diagonal of symmetry. That is the diagonal that cuts things in half. So my 30 gets cut in half, not my 56. Good job. 15, 15. In a kite, just like in a rhombus and a rectangle really, and a square, you get to do Pythagorean theorem a lot because you've got lots of right triangles. So you're going to want to do Pythagorean theorem. 25 squared minus 15 squared. Pythagorean theorem, you get 20. It's called a Pythagorean triple when that happens. So if KS is 20, then we would just do 56 minus 20. Because the whole diagonal is 56, we've used up 20. So we've got 36 left. And then we just need to do Pythagorean theorem one more time with this triangle, 15 and 36. And we got lucky again. Miss Tanton chose a Pythagorean triple again to be really nice. So 39. So SI is 15, KS is 20, and IT is 39. Isn't it nice when we don't have to solve for X? I love just like finding missing sides and angles without having to do algebra. Isn't it fun? It's like a puzzle. I think this is one of our last ones. If you have to go, that's fine, but I'm going to keep working until my bell rings here. I'll keep recording as well. So the first thing I told you to do is, boom, add right angles. I'm going to label what we're given. MNO, that whole angle is 72. OLM, that whole angle is 98. And then I'm going to bold my diagonal of symmetry. So I'm aware of what diagonal is cutting things in half. So it's that green line's job to cut things in half. So let's just go ahead and cut those angles in half. 98, cut in half. $72, cut in half. And then you can find all the other angles, guys, by just subtracting from 90. So 90 minus 49, the complement of 49, 41, 41. And the complement of 36, 54, 54. And now we know all of our angles of a kite. Am I going too fast? I don't know if I'm giving y'all enough time to think. On your trapezoid worksheet, and then tomorrow you're going to have a worksheet where the front is trapezoid and the back is kites. And all day tomorrow you just get to practice. Why are you both saying that? Can you watch what? Oh, the video! Oh, the kite video! I thought you wanted to watch the video I just recorded. I was like, you were here for the lesson. 8th graders, I'm not going to be here tomorrow. That's as loud as it gets. Arsham, you don't have to take a CBA. Up to the highest height. Have y'all seen this movie? And send it soaring. Why would y'all not be able to use a calculator? Why? That's weird. You get to use a calculator on the star? That's weird. Really? Don't use calculators? So, you had to multiply stuff by pi? So, okay, that's enough of the video. So, are y'all allowed to use calculators on the star? Do you know? Do you want a quick multiplying and dividing lesson? So you get to use it on the EOC, but you can't use it on the CBA, which is testing you to see if you know what you need to know for the EOC. That makes no sense. No, your EOC, your star is going to be 8th grade. It's not going to be Algebra 1. It's going to be 8th grade math. You've already taken the Algebra 1 star. Addition lesson, Quan. Come on. Bye. Wait, guys, I need to tell you. I'm not going to be here tomorrow. I'm not going to be signing in tomorrow. So you're going to work on whatever you need to work on. There's a worksheet called Trapezoids and Kites. You definitely need to do that one. But if there's some other homeworks you haven't done, then do those as well, please. Okay? We're going to have a quiz on Monday. You're welcome to sign in and talk to each other about math. No, Arsham, I'm not going to be here. You can sign in and talk to each other about math. But don't sign in and goof off the whole period, because I know y'all do. I sign in later and I check your chat. What if you're not going to be here tomorrow? I have to take the CBA. Well, then you just need to do the worksheet that they're going to do in class. You're not going to miss a lesson, Hussein. You're not going to miss a lesson because I'm not teaching a lesson. I taught both things today. Arsham, you, the 8th graders don't, you have a quiz tomorrow. So just make sure you know your parallelogram. Make sure you know this side of the family tree by tomorrow, Arsham. Not this side. This side. Bye, Carson. Okay.